In this segment, we're going to talk about what chemical formulas are and how to do some very basic chemical formula calculations. Oftentimes, things are not found as single elements. They're going to be often combined with another element, and when they do combine with another element, they're sometimes called molecules. So molecules are particles that are composed of two or more different atoms that are chemically bonded together. That means that they're stuck together. They don't fall apart very easily. For example, to look at a car, we would say it has the body of the car and it has four wheels. Yes, that's very simplistic, but it gives you an idea of that. We look at it, we describe it in a certain way. Those four wheels are attached to the body of the car. They don't come apart very easily. A molecular formula represents the ratio of those particles. So in the case of a car, we would say it was the car body plus four wheels. If it were a bicycle, we would say there was the bicycle body plus two wheels, and that would be a different formula. So the formula for a car would be represented as body, we'll put the letter B, and then wheels, we'll put the letter W, so that would be B, W, and then the 4. And we're going to write that 4 as a subscript to indicate that there are 4 of the thing right in front of it, which is going to be wheels, so BW4. If we were looking at a bicycle, it would be the frame of the bicycle, so we'll put the letter F, and 2 wheels, so that would be a W with a subscript 2. So we get different formulas using different parts or different elements, and that's what we're going to see with these compounds down below. So let's read through them and see what they tell us is present. You should recognize those element symbols from previously, and that should help you to figure out what the parts are. So let's look first at letter A. Letter A has H2O. Most people know what this formula is. This is water. But we can read from here that there are hydrogen and oxygen present. Those are the two types of elements present. And then what is the ratio? Well, you should be able to see that there are 2 hydrogens for every 1 oxygen. Let's try that for letter B. What are the elements present? You should see that there is phosphorus and chlorine. How many phosphorus? Just 1. How many chlorines? There's 5. For a total of 6 atoms that are present in one molecule of PCl5. Let's look at letter C. Go ahead and tell me what elements are present. You should see hydrogen, phosphorus, and oxygen. And now let's look at the ratio. We should see that there are 3 hydrogens, 1 phosphorus, 4 oxygens, which gives us a total of 8 atoms. That's 3 hydrogens, 1 phosphorus, and 4 oxygens. Now the last one has something that's a little bit different, and it has parentheses in it. So looking at letter D, we see open parentheses, NH4, close parentheses, subscript 2, and then CO subscript 3. So we can tell what the different elements are by just looking at each part. We see that there is nitrogen, hydrogen, carbon, and oxygen. And again, you should know all of those elements already, so that kind of makes it easier to spot, hopefully. Now what the parentheses do is the parentheses are like a multiplier. So everything inside of that parentheses is going to be multiplied by the number 2 in this case. So that whole group is being repeated twice. The parentheses are used when we have something that has a common group name. So for instance, if we were looking at the car, we said that there is 1 body and 4 wheels. But the 4 wheels are actually composed of a hub and a tire. So each one actually has 1 hub and 1 tire, but altogether we call that a wheel. And that's similar to this. In this case, what's inside of the parentheses has a special name. We'll talk about that in Unit 2, but it has a group name, and so we're going to write it that way as if it were, in this case, a wheel. And so the formula would have been body, and then hub, and tires, but there are 4 of those, so we'd put that in parentheses and put a 4 subscript to say that there's 4 hubs and 4 tires for a total of 4 wheels. Focusing on letter D, we can look at first what elements are present, and you should be able to identify those first. They are nitrogen, hydrogen, carbon, and oxygen. Now let's find out how many of each there are. So for the nitrogen, it's inside of the parentheses, and there's a 2 on the outside, so there are 2 nitrogens. The hard one is hydrogen. It has 4 hydrogens in the group, and there are 2 of that group, so that gives us a total of 8 hydrogens. For the carbon, there's just 1, because there's no subscript after it, and then we have oxygen, which has a 3. And that's how we read the chemical formulas. Now to count the total number of atoms present in this compound D, we're going to see that there are 2 nitrogens, 8 hydrogens, 1 carbon, 3 oxygen, for a total of 14 atoms. Next, let's look at some calculations we can do with those formulas. Before we talk about the calculations we can do with those molecular formulas, we need to quickly review what an atomic mass is. An atomic mass is how much one atom weighs, and those are going to be given in AMU. We'll talk later about how those are found, but for the moment we just need to know from the periodic table we can find the average mass of a single atom, and that will be found as the atomic mass in AMU. And recall that that atomic mass is found on the periodic table. It is the number just below the element symbol. This is an average mass for how much those atoms weigh. It doesn't tell us how much exactly one weighs, but it does tell us approximately how much something weighs, and we call that its atomic mass, and it's measured in atomic mass units, which is abbreviated AMU. So what is the atomic mass for nitrogen? First we need to find nitrogen. It's over here. We'll look at it and focus on it, and we see that it has 14.00674. Your periodic table may say 14.00, and that's fine. For us, we're just going to say it's 14.00. That is the atomic mass of nitrogen. Okay, now you try it. What is the atomic mass of carbon? So let's find carbon. There it is. Now let's focus on it. We see that its atomic mass is 12.0107. And we're going to say that's 12.01 in this class, and that is our atomic mass for carbon. So we would write that as 12.01 AMU. Now we're going to put those together to do some of our chemical formula calculations. For this first set of calculations, we're going to be looking at something called the molecular mass. The molecular mass, also known as molecular weight, is the sum of all the atomic masses of the atoms in the molecule. So we look at what atoms are present and we add them up and we find out what is the molecular mass. And since this is the sum of the atomic masses, the units will be AMU, atomic mass units. For example, if I told you to just go to the store and buy me 1 apple and 2 grapes and asked you how much does that whole package weigh, you would say, well, the apple weighs 16 grams and the grape weighs 1 gram. So do I have a total of 17 grams? No, I would have 18 grams of fruit because I have 2 of the grapes. So we would see that I have 16 grams of apples plus 2 times 1, which is 2 grams of grapes, for a total of 18 grams of fruit. To do the chemical formula calculations, we're going to need to use a periodic table. I'm going to take just a small portion of the table because the elements that we see here are listed in that portion of the table, and we're going to use that to do the chemical formula calculations. But remember, it will always be from the whole periodic table. We're just looking at a certain corner of it for the moment. Now let's find the molecular mass for each of the following molecular formulas. The first step in this process is to find out which elements are present. The second step is to find out how many of that element is present in each molecule. The third step is then to find out what is the atomic mass of each of those elements. And finally, we're going to add that all up to find out what the total molecular mass is. Let's start with letter A, which has H2O. Here we see the atoms that are present are hydrogen and oxygen. And in our formula, we see that there are 2 hydrogens and 1 oxygen. The atomic mass of hydrogen is 1 AMU. The atomic mass of oxygen is 16 AMU. And to find the total mass of each of those, we're going to multiply by how many there are. So there's 2 hydrogen atoms times how much it weighs, which is 1 AMU. So 2 times 1.0 is 2.0 AMU. And we have 1 oxygen atom times its atomic mass, which is 16.0 AMU. And our total then is 16.0. The total mass of the whole formula H2O is 2.0 AMU plus 16.0 AMU for a total of 18.0 AMU. Notice that for this class, we're only going out one place past the decimal point. That's just to kind of keep things simple. So we're going to round everything off so it's just one place after the decimal. In more advanced classes, they will use everything that's on the periodic table, but for here, we're going to use one place past the decimal. So let's try letter B. Letter B has the formula PCl5. Step 1, find the elements present. We see that we have phosphorus and chlorine. How many of each do we have? We have 1 phosphorus and 5 chlorines. And now we're going to find the atomic masses of each of those atoms. Phosphorus has the atomic mass of 31.0 AMU, and chlorine has the atomic mass of 35.5 AMU. Now let's look at the mass of each of those elements present. So we have 1 phosphorus, its mass is 31 AMU, for a total of 31 AMU of phosphorus. For chlorine, we have 5 of those. Each one of them weighs 35.5 AMU, for a total mass for chlorine of 177.5 AMU. We add those together to find the total mass of PCl5. So we have 31.0 AMU plus 177.5 AMU, and we end up with 208.5 AMU. Now let's look at letter C. Formula that we're looking at is H3PO4. The elements present are hydrogen, phosphorus, and oxygen. We have 3 hydrogens, 1 phosphorus, and 4 oxygens in this formula. The atomic mass of hydrogen is 1.0 AMU. The atomic mass of phosphorus is 31.0 AMU. And the atomic mass of oxygen is 16.0 AMU. Total mass of just the hydrogen then is 3 times 1.0 AMU for a total of 3 AMU. The total mass for phosphorus is 1 times 31 AMU with a total of 31.0 AMU. The total mass of the oxygen is 4 times 16.0 AMU, which is a total of 64 AMU. We add all of that up to find out the total mass of the H3PO4. That means we have 3.0 AMU plus 31.0 AMU plus 64.0 AMU for a total of 98.0 AMU. And finally, let's do letter D, which has the formula NH4 parentheses 2 CO3. We start by first finding out which elements are present, and here we see nitrogen, hydrogen, carbon, and oxygen. Next, we need to find out how many of each element is present. So remember that 2 on the outside of the parentheses is a multiplier. So for nitrogen, we should see 2 nitrogens. For hydrogen, we should see 8 hydrogens. For carbon, there's 1 carbon. And for oxygen, there are 3 oxygens. Next, we're going to find out the atomic masses of each of those elements. Nitrogen is 14.0 AMU. Hydrogen is 1.0 AMU. Carbon is 12.0 AMU. And oxygen will be 16.0 AMU. And now we multiply to find out the mass of each of those elements. We have 2 nitrogens. Each one weighs 14.0 AMU for a total of 28 AMU. We have 8 hydrogens. Each one weighs 1.0 AMU for a total of 8.0 AMU. We only have 1 carbon. It weighs 12.0 AMU for a total of 12.0 AMU. And we have 3 oxygens. Each one weighs 16 AMU for a total of 48.0 AMU. And finally, we add all of that up, so we have 28.0 AMU plus 8.0 AMU plus 12.0 AMU plus 48.0 AMU for a total of 96.0 AMU. And that is the molecular mass of NH42CO3.